Right now we're going to go through the entire lesson of transformations of functions. We're trying to look and see how these quadratics specifically, what their translations and transformations occur within them. So if you miss a lesson or if you want a little extra practice, a little extra review, you can go through this lesson. Hopefully it will help and make a little bit more sense. So let's go through some here. I want you to take out your calculator. Whatever calculator you've got will be just fine. I want you to graph this one. As y1, just type in x squared. Hit pause while you type that in. Hopefully you found out that your graph looks something like this. Now the next thing, now I want you to leave that one in there, but this time for y2, I want you to enter in something else. I want you this time to enter in x squared minus 2. So do the same thing, but x squared minus 2. I want both of these graphs in your calculator. That way you can see the difference between the two. Hopefully you saw that this one was the exact same graph. The only difference was that it went down 2 units. That's going to become important. What we're noticing here is this minus 2. That means it's the exact same graph as this one. Everything is translated, is what we'll call that one. Translated down 2 units is all. Now I want you to do another one. Plug this one into your calculator into y3. This is x squared plus 3. And I want you to think about it on what you think this graph is going to do. So go ahead and type that in now and then push play when you're ready. Hopefully you got a graph that looks like this. Again, it is the exact same graph this time because we have a plus 3 over here. This one is going to be translated up 3 units. In other words, the start of it, the origin went up 3 units. If you want to talk about it or think about it in relationship to its origin, then you'll probably be pretty good on most of them. All right, so we've got all of those. So basically this extra number here moves the graph up and down. It moves it down if it's a negative number, up if it's a positive number. All right, let's look at this one here. We also have something called a horizontal shift. That's when it moves side to side. This works if it is in vertex form. Okay, we're going to get into that right now. This is what we call vertex form. This is, if you'll notice here, we have parentheses and it's squared right here. Then there's some other number here, k, and k can be 0, so maybe there isn't a number there. But the big thing is the parentheses with the squared here. H, this number here involves the horizontal shift. That's the one from side to side. K, this number at the end here, involves the vertical shift, up or down. We kind of just saw the vertical shift there. But the horizontal shift is going to be important. Now, the vertex on this one, we don't have this big long equation we have to do to try to figure out. We don't even have to graph it, then try to calculate it. It's going to be a very, very simple one. It is whatever H is, comma, K. So whatever this number is right here, comma, whatever this number is, that is our vertex. That's why we call this one vertex form, because it's very easy to identify what our vertex is. Okay, so let's look at one here. I'd like you to go ahead and graph this one. F of x equals x squared. So just put that in for y1, x squared. You may already have that in. You can delete the y2 and y3. We're going to get to those. So y1, x squared should look something like this. Now what I want you to do is for y2, I want you to go ahead and type this one in. This looks similar to the one that we were doing before, except this one's in parentheses now. So we've got an x minus 2 squared, that whole quantity squared. Now, we'll show here this one slid over to the right 2 units. Now remember, here our h value is actually 2. It's not a negative 2. Okay, it is a positive 2. Whatever, some students like to look at it and say, okay, whatever the opposite of what these two values are, whatever the sign is, change the sign, and that's your h value. That works. But as long as it's in this vertex form, whatever this value is right here, or if you want to think about this whole thing here and change the sign, that's what your h value is. So this h value is 2. That means you moved in the positive 2 units. Now let's bring another one in. Type this one in as y3 on your calculator. And push play whenever you're ready. Hopefully you got something that looks like this, in which the whole graph is slid over 4 units. H in this case is negative 4. Again, many students like to just think of this and just go, okay, we're just going to change the sign. Whatever the sign is, we're going to change it. Right now it's positive 4, so we're going to change it to a negative 4. That's fine. That will work. That is your h value for all of these. Okay, now the k value, we talked about the vertex on this. The k value on all 3 of these has been 0. Because remember that k value is what moves it up and down. None of these have been moved up or down. All of these are still with a y value of 0. All of these are right on the x-axis. All right, so now let's look at one here. These are two different ones. What I want you to start thinking about is what is the difference, what shifts occurred between the blue graph and the red graph. So the blue graph, this is always going to kind of be our base one, if you will, and we want to see what shifts occurred between that one and this one right here. Okay, so let's go ahead and graph both of these. And you can see, all right, we've got a couple. It appears to be roughly the same graph, this red one is, as the blue one. It's just kind of moved spaces a little bit. Kind of shifted up and to the right a little bit. Well, we want to identify h and k, so let's bring in that graph right there. Remember, h is this number here in red. Again, many students like to think about it as the opposite of whatever this sign is here. So h is actually going to be 2. K is this final number here. We do not change the sign on k. Okay, so my vertex on this one is 2, 4. So that made it very, very quick to find the vertex. And that's, again, why we call this one vertex form. It's very, very fast to find the vertex. Now, what we're going to do is ask for the translations. And the translations here, now remember, the h moves it side to side. That means it's going to go to the right 2 units. Okay, because h is positive 2, it's going to go to the right 2 units. Then it went up 4 units. That's our k value, went up 4 units. What I typically try to tell students is, okay, once you find the vertex, that tells us everything we need to know. Remember, the vertex is your x value here. This is the one that goes side to side. This goes in the positive direction, so in the right 2 units, and right here, this 4 went in the positive direction, up 4 units. Now, you need to get in the habit of identifying what all of the shifts are that occur within these graphs. That's what you're going to be doing for a lot of your homework and on the tests. Okay, let's try one here. You go ahead and try this one. What I'd like you to do is to identify, number 1, what the vertex is, and number 2, what the shifts are that occur. So go ahead and push pause right now. Whenever you're ready, come on back and you can push play and check your answer. All right, well, hopefully you identified that the vertex on this one is -2, -3. And again, what really helps a lot of students if you just take that vertex and then you write what happened. Okay, this one went to the left 2 units because it's -2, and it went down 3 units because it's -3. That's fine. That's perfect. That's what we need at this point. All right, let's try another one here. Go ahead, and it's between the blue and the red one. This one that I have in black is just the one underneath red. So it's the same thing as the red one. So I want you to go ahead and find the vertex and describe what shifts are that occur. Go ahead and push pause now and push play when you're ready. And hopefully you got this as your answer. Again, the h value is opposite of whatever's inside of this, if you want to think of it that way. This is a +3. That means your h is -3. And then the k value is whatever's on the outside. This time it's -2. So this one says that we should go to the left 3 units and down 2 units, okay? Hopefully you identified that this one was the one that we just did. So the vertex on this one is -3, -2. Now I want to find out what the axis of symmetry is and what the y-intercept is. Now this goes back to our previous lesson that we covered. The axis of symmetry occurs, it's a vertical line. So here's our vertex right here. It's a vertical line right here, right straight up and down here. So we take our x value in this case, which is -3, and we write an equation on that. So x equals -3. That's going to be your axis of symmetry. Now for the vertical intercept, we have to remember that the vertical intercept occurs when x equals 0. So now what we're going to do is we're going to take this equation, either the one in red or the one in black, it doesn't really matter, they're the same equation. We're going to take this equation and we're going to plug in 0 for x. Now previously we could just take this final number here because all the other ones had an x next to it, which meant that they all canceled out. This one we cannot do that. That will change our answers. It'll get us an incorrect answer, so we don't want to do that. Because -2 says it's our vertical intercept or our y-intercept. If we look over here at the graph, it does not cross at -2. That is incorrect. So you want to get in the habit of just plugging in 0 right here for x. So let's do that. Now I wrote it down here. It's the exact same equation. I just wrote it down here so it's a little bit easier to kind of understand. I'm plugging in 0 for x. That's all I'm really doing. I'm going to find whatever my y value is. Okay, 0 plus 3 is just plain old 3. 3 squared is 9 minus 2. So 9 minus 2 is 7. So my y value is 7. And if you look at the graph over here, that's where it crosses right there at 7. Now, with my y value being 7, I know what my x value is. That's 0. So you'll need to write it as an ordered pair. it needs to be 0, 7 with parentheses around both of those. This is how you'll have to input it into the online system. Okay, so now let's get some more practice on that. Here are two. I want you to identify the vertex, the axis of symmetry, and the vertical intercept. So go ahead and try that now. Push pause, and when you're ready, come on back and push play. Check your answers here. Hopefully that worked out. Remember that your vertex is -6, -4, so that means your axis of symmetry is -6. You also want to be thinking about, oh, the other thing is on your y-intercept that you must write it as an ordered pair. I have both of these written as an ordered pair. Make sure you get in the habit of doing that. But the other thing I want you to start thinking about is, okay, what shifts are occurring with these two graphs? So this one is going to go to the left 6 units and down 4 units. That's going to be my shifts that occur. This one's going to be to the right 2 units and up 12 units. Those are the things you want to be getting in the habit of starting to think about now. Okay, so let's try 2 more. Go ahead and push pause now. And whenever you're ready, come on back and push play. Check your answer on these 2. Hopefully that you got the right answer here. And again, you can kind of look at some shifts that occur here. We've got a couple other things here. We've got a 3 out in front and a negative out in front as well. So that's kind of going to throw us off just a little bit. We're going to get to those in just a moment. But again, you want to make sure that your y-intercepts are written as an ordered pair. Your axis of symmetry is not 4. 4 is just a number. X equals 4 is a vertical line right at 4. So you need to make sure you write those as x equals 4. Okay, now I want you to go ahead and graph this one. This is a -x squared. And we've graphed a lot that were x squared, and those are the ones that are smiley faces. So -x squared, that's our frowny face. Okay, so we need to be thinking about it in terms of what this negative does out in front. It flips it upside down, if you want to think of it that way. That would be a fine way to think of it. Okay, now that you've got that one graphed, let's go ahead and y2, let's type in this one as your graph, -3x squared. Now we saw that 3 in a previous problem, and now we're going to see what it does to our graph. It's actually not going to shift the vertex at all. That's going to remain the same. But what it's going to do is make the graph narrower. So here's our graph. Instead of being wider like this one over here, this one's going to be more narrow. Okay, more narrow. Now let's go ahead and bring in another graph. This is -1/3 x squared. Well, -1/3 x squared is going to be a really, really wide graph. So here's how we're going to signify which one's which. The negative flips it upside down. If the number here is greater than 1, that makes it more narrower. If it is less than 1, such as 1/3, I'm not too worried about this negative. I'm just worried about the number directly next to it. But this is 1/3, so 1/3 is less than 1. It's between 0 and 1. So because of that, it makes it wider. And if you want to think of that, that number less than 1 or greater than 1, regardless of this sign right here, you'll be fine. That will work. Even if it's a positive, if this were a positive 3x squared, it would be more narrow than this graph, which is an x squared. And if this one were a positive 1/3 x, it would be more wide than this one here. Okay, and that'll take more practice. Practice is going to be key on this particular one. All right, I want you to write all of the distinctions, what all the translations occur. Is it left so many, right so many, up or down, narrower, wider, upside down, right side up? Right side up would be one that is a positive. I want you to go ahead and do that for each one of these, and I want you to list them all out. Go ahead and do that now. Push pause, and when you're ready, come on back to check your answer. Okay, check your answer here. Now, this one translated 6 units to the left. That's because my h value here is -6. Down 4 units, that's because my k value is -4. It's upside down. Upside down comes from this negative right here. And it's narrower. Remember, if this number right here, not talking about the sign in front of it, just the number. If the number is greater than 1, it's going to be more narrower. If it is less than 1, such as in the second one here, 1/2 is definitely less than 1, it is wider. Now this one's right side up because there is no sign here, and I'd like you to write that. Get in the habit of doing that. It'll be just fine. This one, the graph is translated 4 units to the right because my h value here is actually +4, and 6 units up. All right. Let's do this one, and go ahead and push pause now. Same thing. I want you to list all of the distinctions with each graph. Push pause now. When you're ready, come on back. Okay, check your answers here. Now this one is wider. It's wider because it's 1/4. Remember, 1/4 is less than 1. Now the graph is right side up because it's a positive here. There's no negative in front. The graph is translated 2 units to the right. It's 2 units to the right because my h value is +2. My vertex on this one is 2, -5. And that means it's translated 5 units down. Now this one over here, we have narrower. It's narrower because of this 2. The 2 is a number that's larger than 1, so that is going to be narrower. It's upside down because of this subtraction sign here. It is, let's see, the vertex on this one is -1, 4. That means it goes 1 unit to the left and 4 units up. That concludes the lesson. If you need to, you can go back in and review it and get a little more practice on it. Hopefully that helps.